Hello everyone again. So I hope you are all having a good day and staying safe at your houses. So for today we will be discussing time value of money. So this is the next lesson for our engineering economy subject. So for the time value of money, it is quite confusing for most of all because yeah, this is where you can add or control the flow of the money. Okay, so we have here two definition. We have first the equation of values. Okay, so for the equation of values, it is the resulting equation when comparing two sets of obligations at a certain point of comparison called the focal date. At the focal date, the equation of a value is sum of the cash inflows is just equal to the sum of cash outflows. So, or at the focal date, there exists cash flow equilibrium. So, what this basically means is so we can say here that the cash inflows are your income because it's inflow. So, that's your income, and the cash outflows will be your expenses. Simply at the focal date is that is where the money or the expenses and income are equal. Okay. So to put for the next one, let's go to the next one. Focal date, where the sense of obligation can be added or subtracted to one another. Okay. So let me elaborate or explain to you guys more of this one. So let's say we have here a timeline of the money. Okay. Timeline of the money. Okay. Oops. So let's say we have here multiple years. Okay. So let's say this is our year zero and year one. This is your year two, um, year three, year four, and year five. So remember that what we call this is the cash flow diagram, or you can also say that this is your CFD. Okay, so let's say that we have here a at the first year. Let's say at the first year that we have here 10,000. Okay. So we have so for me, my standard is all the arrows going down are my expenses and all my arrows going up are my income. So let's just put it. So all arrow going up, okay, lahat po ng going up, and then I think I got it backwards. Anyways, let's say this is my income, all my going up, and this will be my expenses. There you go. And then let's just put some arrows here so you can see that these are all expenses. These are all expenses. Okay. So we have here an expenses of 10,000. And let's say that we have another expenses at the fifth year. Let's say we have another expenses here, which is, let's say 20,000. Okay. And then how about let's have here another line about here at that second year. Okay. Let's say from here, there you go. And then, oops. Let's say we have here 5,000. And then let's add some more. Let's add some more here. I just replace that one with a line here. And then let's say that we have here how about 8,000. Oh no, let's make it 3,000 only. Okay, we have. As you can see, we have here our cash flow diagram again. So we have here a year, zero from two, 0 to 5. We have year 0 to 5. This is your fifth year. This one. Okay, so from this, as you can see, we have again, it's all the hours going down is your expenses, all the hours going up are your income. So it doesn't matter if you interchange these two, as long as you know your standards. But for me, this is my standard. All the hours going down are my expenses, and all the hours going up is my income. So that I can have a simple or simpler solution. Okay. So next, let's say, so as you can see, we have at the year one, we have 10,000. We have an expense of 10,000. At for the year two, for the for the year two, so we have a expense of income of 5,000. And for the year five, we have expense of 20,000 and also an income of 3,000. So what does the equation of value means, or the focal date? Okay, so focal date, this is where you will bring all your money. So in order for you to add or subtract it, for example, you cannot add 10,000. As you can see, 10,000 and 20,000 are both expenses, right? But you cannot simply add them. You cannot say that the total expenses for this one is 30,000. That because that's 10,000 plus 20,000, that's 30,000. You cannot say that because 10,000 is at year one. Therefore, these expenses occurred at year one, while this expense occurred at the year 5. Therefore, they are in different timelines. The other one is year 1, the other one is at year 5. So, therefore, you cannot add those two. Okay? So, you cannot add those two. The same thing with 5,000 and 3,000. Even though that 5,000 and 3,000 are both income, you cannot add those because, again, they are in different timeline. Okay? The same, as you can see, if this is an expense, this is an income. Okay, so if that is an in expense income, therefore if you will subtract those, that's 10,000 minus 5,000, that's 5,000. Okay, that is 10,000 or minus 5,000, that will become 5,000. That is also wrong. You cannot do that because, again, they are not in the same year or same timeline. That is where the focal date will go in. Again, the focal date where the sets of obligation can be added or subtracted to one another. Again, you can only add or subtract money in the same timeline. For example, again, therefore, I can add or subtract 20,000 and 3,000. Therefore, I have an income of 3,000 and I have an expense of 20,000. Now, if I will subtract those, that will become 17,000. That I can do. Why? Because they are both in year 5. Okay? So they are both in year 5. That's why I can do that. So that is what the equation of values or focal date means. Okay? So that means if I want to add 5,000 to these two obligations or to these two payments, I have to bring first 5,000 into year 5 before I can do that. Same goes with 10,000. If I want to add 10,000 to these two obligations, I need to bring 10,000 first into year 5. Or for example, um I want to add 10,000 and 5,000. There are two ways. It's either I bring 10,000 into year 2 or I bring 5,000 into year 1. I hope this is clear because we really need this for this time but for this lesson, because for me, time value of money is the hardest lesson in engineering economy that requires a lot of explanation and quite confusing. And so a lot of people gets confused here. And so I think so that you can understand this more, we can go into some sample problems. Okay, let's go to our first problem. So for the first problem, we have Engineer Salvador has to pay her bill in credit card installment basis. So first payment is 10,000 at the end of first year. So 20,000 at the end of third year, 30,000 at the end of sixth year, and 8,000 at the end of eighth year. So how much is the total payment of Engineer Salvador after 10 years at the rate of 10% per annum? Okay, so let's evaluate this first. Okay, let's just put the all the givens first, all the given. So I you always do this, okay, so that you won't get confused later on. So let's put the given. So we have a given of we have multiple payments, right? Let's say the first payment, okay? The first one we have 10,000 at first year. At first year. So we have the second payment which is 20,000 at third year. Third year. Okay, so we have the third payment of 30,000. Ano? Is it? Yeah, it's 30,000. It's 30,000 at 6 year. And then fourth payment will be 8,000 at 8 year. So all of these, of course, has a interest rate, and and the given interest rate is 10% per annum. So that is per annum. That also means annually. Okay, so we can say that this is your I when when the interest rate is compounded annually. The I and J are just equal because again the N is just equal to 1. So we can say that I or J is just equal to 10%. But again, of course, you won't be using the 10%, you will be using the 0.10 value. Okay, so what is required? Required. We are required to find how much is the total payment of Engineer Salvador after 10 years. So after 10 years, so we are required to find total payment at 10th year. Okay. Okay, so let's start with the solution. No, I think we can start with the cash flow diagram or the CFD. So this is important that you must know how to construct a um, cash flow diagram in order for you to visualize more the money or the cash flow or the flow of the cash. Okay, so let's just so these are all expenses, right? Because that is a credit card to be paid. Okay, so let's just put it here. Okay. So let's say this is our zero. I just make the years with payments longer so that I have a space for writing the payments, the amount of payments. That's 0, 1. We have here the 2. We have 3, right? We have 3, and then next one is 6. So 4, 5, 6, 6, 7, 8, 9. We have to the total midweight is at 10th here, right? Okay. And then we can have that. Then let's just put some arrows. Some arrows. Okay. So those are all no, that's one. This one. How many payments do we have? We have four, right? Did I miss the 8 years? So this 10th, 9, so this year 8. Okay, so let's make it longer. So this is how you construct a cash flow diagram. So I could skip this one while I'm doing the cash flow diagram, but I want you to know how to construct a cash flow diagram so that you'll be able to know how to construct it step by step. Alright, so let's put all the expenses. No, let's just put the years first. So this is 0. This is year 1, year 2, year 3, 4, 8, 9, and then 10. Okay, so let's put all the values or the expenses. That is, we have here 10,000, right, for the first year. 10,000 for the first year. We have for the third year, we have 20,000. For the sixth year, we have 30,000. And then for the eighth year, we have 8,000. And then for the last one, we have here what we are looking for, which is, let's just call this one F10. So why F10? Because again, so our aim here, so remember that we have an I, so we have an I given, so I is just equal to 10%. That's compounded annually or per annum. Okay, so let's just call this F10 because what we will do is, again, we are looking for the total payment of Engineer Salvador. So again, you cannot simply add 10,000, you cannot simply add 10,000, 20,000, 30,000, and 8,000. Then that will be the total payment. That is not as simple as that. So what we will do is we have to bring 10,000, 20,000, 30,000, 8,000 to year 10. Okay, so we will do it one by one. So we will bring 10,000, 20,000, all those values into the year 10. Therefore, we can say that um, we can say that year 10 is the focal date. Okay. So what we will do here is we have again we'll be bringing all these values into year 10. So that at that point all those values are already at the year 10. Therefore, again, from my explanation earlier, you can only add values which are in the same year. That's why we have to bring those first all in 10th on the 10th year before we can add them. So but we will know the total payment. Okay? So so let's solve we will solve it one by one. Okay, so let's solve this one first. Let's say that this will be your F1, this is your let's say this is F3 because that is at third year. Let's say this is your F6 and this will be your F8 or the 8th year. Okay, so we will be bringing this 10,000 into the future to the 10th year. So we are going right. Okay, so remember, okay, so let's first solve for F1. Remember that the formula that we will be using is we only have two formulas for the compound interest, right? That is F is equal to P times 1 plus either I or J over N. Let's just put this here I because we're using I raised to Y N, or you can also use P equal to F times 1 plus I raised to negative YN. Okay. Okay, so for the first one, we have to bring 10,000 to the 10th year. Okay, 10,000 to the 10th year. So that's how many years? Let's just put first the present value. Okay, with respect to the 10th year, to the year 10, 10,000 is your present value, right? So we can have here 10,000 times 1 plus what is your I? Our I is 0 0.1, so we can have here 0 0.1 raised to Y. How many years is that? So that is from year 1 to year 10. So that is 9 years, right? That's 9 years. So we can have here your Y will be 9 and of course your Y will be 9 and of course your N is just 1 because that is per annum. Okay, so you will have a value of that. So next one we have here, no, this is not F2, this is F3. So for the F3, again, we'll be bringing this into the 10th year. Okay, so we have here 10,000. That again is 1 plus 0 0.1. We're going right. So remember, if you're going right, your exponent must be positive. If you're going left or going to the past, your exponent must be negative. So since we're going right, this must be positive. So that is from year 3, okay, year 3 to year 10. So how many years is that? Again, that is 7 years. So we have a value for that. We will be solving that later on at the same time. So f6 now will be equal to, now this will be, again, we'll be bringing f6 into year 10. Okay, so this is 30,000 times 1 plus 0.1 raised to, how many years is that? That is 6 to 10, that is 4 years. 4 times 1 and equal again. And then for the last one, we have f8. So f8 now will be equal to 8,000. So 1 plus 0.1 again. And raised to, how many years is that? That is from 8 to 10. So that is 2 years. 1. And then equal. So let's try to solve this one by one. I'll also try it on my calculator. The first one is we have 10,000 times 1.1 raised to 9. We have here 23,579.469. Okay. Next one, we have 10,000 raised to 0.1 raised to 7. We have here 38,974.342. Next one will be 30,000. This is 36,300. That's not the exact amount. Oh no, nope. Sorry, I think I got it wrong. This is 30,000 times 1.1 raised to 4, right? So this is 43923. Okay, and then for the last one, we have 8,000 1.1 raised to 2. We have 9680. Okay, so those are the answers. So as you can see, therefore, these values are already in, these values are already in 10th year. Therefore, since those are all in 10 year, or the 10th year or the year 10, you can simply, to know the total payment that India El Salvador did or paid, all you have to do is add all those four, add those four. So adding those, you'll have at 23579.47. Okay, so adding all those, you'll have the final answer of, I think we can make it big. We can make it bigger so that you can see. Total answer will be 116,156.8189. So that will be your total payment that Engineer Salvador paid. So that is your answer. So this is as your year 10 as your focal date. So you can do that. So another one here is you can you can make any date, any year your focal date. It doesn't have to be F10. Okay. So how about let's try how about year 6. Okay, let's try year 6. Um I'll just clear the board and I'll be back. Okay, so let's go for another solution for this one. So supposedly you will have a multiple solution for this one, but of course we will always arrive on the same answer. Okay, so let's see. So for this one, let's say that our focal date, or the focal date again, that's where you will be bringing all the money. Okay, let's say that our focal date is 6 year. Okay, oops. Okay, focal date is year 6. Okay, so focal date is year 6. Okay, so we will be still using F1, F3, F6, and F8. But again, the focal date, remember that is year 6. So what will happen here is, let's first try to solve for F1, okay? So for F1, again, we'll be bringing this into 6 here. So this 10,000 is going to right. Therefore, the exponent must be positive. So that is 10,000 times 1 plus 0.1 raised to positive. But that is from year 1 to year 6. That is 5 years, okay? 5 years, that's yn. And we will have a value for that. We'll be solving that later on. So let's have F3 now. So F3, that is again 20,000. Okay, so 20,000. 20,000 times 1 plus 0.1 raised to, that's year 3 to year 6. So that is 3 years. So 3 times 1, again equal. And then next we have F6. So what will happen to F6? Since as you can see that 30,000 is already at the 6 year, you don't have to do anything with that. That's already at the 6 year. So F6 is just 30,000. That's it. Okay, that's it. And then F8. F8. As you can see, F8 is a little bit different. So as you can see, F1 and F3 are all going right, or they are all going to the future. So F8 now, that is going to left. Therefore, the exponent must be negative. Okay, so that is 8,000 times 1 plus still 1.01 raised to negative, because that is going to left. Okay, it's going to left. That is from 8 to 6. Year 8 to 6. Therefore, you have to go back 2 years times 1 and then equal. Okay, so let's solve this again. Okay, so solving all of these, we have the first one is 10,000 raised to 5. So that is 16105.1. And then for the next one, we have 20,000 raised to 3. Okay, so that is 26620. And then we have 30,000. Don't forget about that. And then we have 8,000, 1.1 raised to negative 2. So this must be lower, right? So 6611.5072. Okay. So again, since all of these are it at the, so all of these values are at year 6. Therefore, we can already add this one, this one, this one, and this one. So adding all of those, we have 16105.1 plus 26620 plus 30,000. 5702. Okay, so we have an answer of 79336.6702. Okay, you might be confused because we didn't get the same answer as before, but this is not yet that's the final answer. We still got, again, we're looking for the total payment at the 10th year, right? But this total payment is at the year 6, at the 6th year, right? So if I will construct again the cash flow diagram, it will look like something like this. So this is, let's say this is 0, year 0, 1, 2, 3, 3, 4. It's year 1, year 2, year 3, 4, 5, 6, 7, 8, 9, 10. What will happen is all of these payments, this 10,000, 20, 30,000, 8,000 are all in the 6th year. So that means this will now look like this is what the cash flow diagram looks like. So we have here a payment of 79336.6702. This one. So you will only have here a single payment. But we are looking for the year 10. Therefore, this is at the 6th year, we have to bring this value again into 10th year. Okay. So bringing that, we will again apply this formula. So applying this sorry, not that one. This formula again. So you are going to write, therefore your exponent must be positive. So you'll have here the total payment or the F10 now will be equal to this one. Okay. That is 79336.6702 times 1 plus 0.1. Again, you're going to write, right? You're going to write, therefore your exponent must be positive. So again, this is from year 6 to year 10. Okay, year 6 to year 10, that is 4 years. So that is 4 times 1. Okay, so let's check if the answer will be, let's try this on your calcu, 7 9. Okay, so your answer will be 116 116 1568188. Okay, so as you can see, we also got the same answer as we did to our last solution. We just have a little discrepancy, but still, the answer is just the same. That is 116156. If you will check, the other answer is we still got the same answer. My point is, you can have multiple solutions here because any dates or any year can be your focal date. Your year one can be your focal date, year two can be your focal date, as long as you know where the money must be at the final time. So for this one, the money or all of the money or all of the payments must be at the year 10. So it doesn't matter where you put the money first, or what doesn't matter what is your focal date, you will always get the same answer. So I hope this is really clear. We can go for another problem. We can go for another problem. Okay, so let's go to the next one. Okay, so let's go to our next problem. So we have a young engineer bought a second-hand car worth 150,000 if paid in cash. So on the installment basis, he paid a down payment of 50,000 and then 30,000 at the end of the 1 year, 40,000 at the end of 2 years, and final payment at the end of 4 years. So what will be the payment if money worth is 15% per annum? Okay, so we have here, how many years is that? That's just 4 years. So I can easily construct that. So constructing the, no, let's just put the givens first, right? Always put the givens first. So we have here given. So we have a we have a total worth of the car is 150,000. So we can have, so that 150,000 if paid in cash. Now if you will pay in cash, that is a present value, right? So we can have here the P. The P is now 150,000. Okay. So we have a down payment or DP. Let's just put it DP of 50,000. Okay. Next, at the end of first year. So first year we have payment of 30,000. We have first year, and then we have the second year. Second year we have a payment of how much? That's 40,000, and then we have a final payment. So we don't know that payment, and that's what we are looking for. So final payment at the fourth year, which is, let's just call that X. Okay. So we are required to find, of course, the X. So this must be any value. So of course, don't forget that it is the money worth the interest rate is 15% per annum. So again, if that is per annum, that's compounded annually, I and J are just equal. So we can have I is just equal to J or 15% or that's 0.15. Alright, so if we will construct now the cash flow diagram, okay, so constructing the cash flow diagram, you'll have how many years? That's just 4 years. Okay, so let's just have our year zero, year one, year two, year three, and our year four. Okay, so we have here a payment of 50,000. Okay, we have a down payment of 50,000. So if you will pay the down payments being paid at that present time, right? So that must be, let's put our years for the 0, 1, 2, 3, and 4. Okay, so this one must be, we have a down payment, you will be paying here 50,000. I think it's alright if I just put here 50K for simplicity. Okay, so that's 50K. So you have a down payment of 50,000. Next, for the first year, right? Okay, so for the first year, you'll be paying this one, which is 30,000 or 30K. And then we have a second year, which is 40,000. 40K. We don't have any payment at the third year, but we have a payment at the fourth year, which is a value of X. And that is what we are looking for, or what we are required to find. Okay. And then these are the total payment of the car, right? This is the total price. Now, if I will, what is the total price of the car at year zero? Okay. Note that the total price of the car at year zero must be how much? It must be this one, the 150,000 must be 150,000. Okay? Therefore, if I will bring every money into year zero, or simply I would make year zero my focal date, 150,000 equal to the sum of all these monies from year 0 to 1, 2, 3, 4 must be 50,000, 150,000. Or simply, we can have, again, we're going to right, going left, right? So this is your DP, right? Your 50,000 is your down payment. Let's say this is your P1 and this is your P2 and this is your P4, no? This is your P4. This is your P4. Okay? So I use P because that we are going present, we are going to the past. Rather, in our earlier problem, I use F because we're going right, because that is a future. Okay, so what will happen here must be um, 100. Okay, let's just uh, make our okay, focal date is year zero. Okay, year zero. Next, we can have here, let's try to put all these monies into year zero. So we don't have to do anything with the down payment 50K because that is already there, right? So we have a DP, okay? We have a DP, and then we can solve for P1. This is equal to 50K, right? 50K, and then P1 must be, that is 30K times 1 plus this one, that is 0.15 raised to, again, we're going left. Therefore, the exponent must be negative. So that is negative. How many years is that? From year 1 to year 0. That is negative 1 times the method of compounding 1. So that is already the value of P1. So P2, we have here 40,000. That's 1 plus 0.15. That is a year 2. Again, you have to go back 2 years. So that is negative again. We're going to left. Negative 2 times 1. And then we have P4 must be equal to whatever value is this. So that must be x times 1 plus 0.15 raised to negative 4 times 1. Okay. So therefore, all of these values is at a year 0 already. Okay. And the this value, the 150,000 is also at the year 0, right? Because that is if paid in cash. Therefore, all of these values, if I will add the down payment P1, P2, and P4, that must be all equal to 150,000. Okay, so rewriting the formula, you will have here 150,000. That must be equal to the value of P1 plus P2 plus P4. Okay, now if I will put all the values there, you'll have here something like this. You have here 150k. Oh, I forgot here the DP, sorry. We have here DP, the DP plus the DP. Okay, so 150,000. P1 is this one. So let's write that one. So that is, I think we can just get the value of that. Let's try to get the value of that. So this is all at the year 0. You already know that this is at year 0. Okay. So getting the value of that, you'll have, okay. So this one is equal to 26086. Let's just try to change the color. Uh, let's make it this one. Nope. Okay, that's 2680. Let's put all the equals here. Equal, equal. You cannot do anything here. And then the next one will be 40,000 raised to negative 2. 3245.7467. Oh, there you go. And then this is as is. Okay, so rewriting this one, you will have here. So continuing this one, you'll have here 150,000 must be equal to the value of P1, which is 26086 is equal, so plus, that's the value of P1. P2 is this one. We have 3245.7467. Okay. Mhm. And then plus the value of P4. Okay. Value of P4 is x times 1 plus 0.015. You can also make it just 1.15 to make it simpler. Raised to negative 4. I will no longer write the value of the 1. And then plus the down payment of 50,000. Now, as you can see, you only have one value missing, which is the value of x, and that is what we are looking for, the last payment. So using the function of shift solve, or you can do it algebraically. So let's try to do it using our calculator for 5 point. You can use the function shift solve. The answer will be x now will be equal to 76376.0480, and this will be our final answer. There you go. So again, in this problem, you can still have different focal dates. It doesn't mean it does not necessarily to be your focal date is zero. You can also make your focal date one, two, three, or four, or anything. So I think that will be all for this video, and I really hope that I was able to help you with your confusion in time value of money of engineering economy. Again, this is one of the difficult or one of the hardest topic in time in engineering economy, and I hope I really help. So if you have any questions, so don't forget to leave a comment down below. Say I will try to answer all of it as much as I can. And of course, don't forget to subscribe and watch also my other videos. If you find any confusion in my solution, all you have to do is comment down below. Don't forget to subscribe. And thank you all guys for watching, and I'll see you on the next one. Bye bye.